All right, lesson number 2, perfect square trinomials. Let's check out what perfect square trinomials are. Okay, what we're going to have here is we have a binomial, a plus b, and we're going to square it. The other situation we might have is when we have a minus b and we're squaring it, right? So those are our two options, really. Okay, so let's look at what happens with each of these. I'm going to expand a plus b times a plus b, because that's what it tells us to do when we square it, right? And what we're going to do from here is FOIL. We're going to get a squared, and we have a times b, which is ab. We have b times a, which is a second ab, so we have two ab's. And then last, we have b times b, which is b squared. Okay, let's check out this one down here. If we expand a minus b times a minus b, again with the foiling, right, we do our a terms first. We have a squared. A times negative b is going to be minus ab. We have a second negative b times a, so that's a second a minus b. And then we have negative b times negative b, which is b squared. So we had two minus ab's, and then we had a positive b squared. Alright, now why did I take the time to do that? Because with these perfect square trinomials, and notice it didn't matter what values we chose, what ended up happening in both situations was we squared the a term, we squared the b term, notice they're both positive, and our middle term we took 2 times the a times the b. That's what we got for our middle term. And what we did was we kept the sign of whatever sign we had on b. Right? Here it was minus, so here we want to take the minus. Okay, so it's pretty simple to do. We're going to do the a term squared, the b term squared, and 2 times a times b, keeping that middle sign. Okay? So let's just see a couple of examples of this done out. And we're not going to expand it anymore. We're just going to use the shortcut now. Okay? So we're going to do our a term for this first problem is x. Our b term is b. We have a plus sign in the middle, so we know that we're going to have positive 2 times a times b. So if we square our first term, we get x squared. What value is in front of this x right now is 1. So I'm going to do, because I know it's positive, I'm going to be doing 2 times our a term, which is 1, times our b term, which is 6, plus our b term squared. Okay. Now, in the future, are we going to have to write out this full length? No, we don't have to. If we're good enough that we can do 2 times these numbers, and we know how to square this, we're okay without having to write it all out. But this is the first time that we're doing this, so it's not going to hurt us to actually write it out. Okay, we've got 2 times 1, which is 2, times 6, which is 12, x, sorry. And then we have 6 squared, which is 36. I apologize, I had to shimmy in the little x right here that I forgot. Okay, it gives us 12x. So that is our perfect square trinomial. Now let's look at another example right next to it. Number 2, we have x minus 12 squared. Okay, again, we're going to square our a term. We're going to square our b term. So this is going to be 12 squared, which is 144. I know that this is going to be minus. So what I'm going to do now is I'm going to do 2 times 1, which is still going to be 2, times 12. So that's 24, and we have an x, so that's minus 24x. That's our expanded trinomial. Okay, we've got one more right here to look at. Okay, this time our a term is 5, so we have a squared, which will give us 25. We know our final term is going to be x squared, because that's our b term, x squared. I have a minus, so we know it's going to be minus in here, so we have to do 2 times a, so 2 times 5 is 10, times our b, which is negative 1x. So we had 10 times 1x, so that's minus 10x. Okay, there's a few u-try problems. Okay, these two right here. I'm going to be writing out the expansion from now on with these, just because I think it's easier to follow if you can actually see it out. You don't have to show those steps, but I'm going to show them in the future. So I have 2 u-try problems right here for you to try. Pause the video, check out how you did, and then resume it when you're ready to go. Alright, let's check this out. As I had mentioned, I'm going to write these full out. Right, so I'm going to do a squared, which is x to the second power. I know this is going to be plus 2 times a, which is x, times b, which is 3, plus b squared, 3 squared. Okay, so we got x squared. 2 times 3 times x is 6x, and 3 squared is 9. Second problem that you had over here, we want to do a squared, which would be 7 squared. I now have that negative that has to go in there. I'm going to be doing 2 times a term, which is 7, times our b term, which is actually an a here, plus our b term, which is a squared. I don't know why I wrote b in there. That should have been an a. Okay, so we've got 7 squared, which is 49. 2 times 7 is negative 14a, and then we have plus a squared. Hopefully you did okay with those two. I have 2 others directly underneath it, and I had you wait on those ones because the a term's a little bit different than what we had before. What you notice now is that we have a coefficient in front of x. Okay, it shows up over here as well, and in your practice problems. Okay, so we're really going to be dealing with it the same way that we would deal with it normally. And this is also why I've decided I'm going to continue writing everything out. It's a little bit easier to do if you know exactly what you're working with. Right? I want to take my a term, the whole thing, which is 5x, and I'm going to square it. I know it's going to be a plus because I have a plus here. It's going to be 2 times my a term, which is 5x, times my b term, which is 2, plus my b term squared. Now, writing it out like this, at least to me, it's a lot easier to see exactly what my first term is going to be. I have 5x squared, which is 25x squared. I don't accidentally put 5x squared because I wrote this whole thing out. Right? It kind of prevents me from making that mistake. Here I got 2 times 5x, which is 10x, times 2, that's going to be 20x. And then we have 2 squared, which is 4. Okay, our example on this side, not much has changed, right? We're going to do our a term, 3 squared. We have minus 2 times our a term again, which is 3, times our b term, which is 4p, and then we have plus 4p squared. Okay, here we've got 9. 2 times 3 is 6, times 4 is 24. So we've got negative 24p. And then we've got 4p squared. So that's 16p squared. So now you have 2 to try on your own right here at the bottom. Like I said, if you take the time to write out these first, it's a little bit easier to get your solution. So try these out, pause the video, resume when you're ready to check your work. Alright, let's check out how you did with these. We want to do 7x squared for our a term plus 2 times our a term, which is 7x, times our b term, which is 2, plus our b term squared. 7x squared gives us 49x squared. 2 times 7 is 14, times 2 is 28x. And last we have 2 squared, which is 4. How'd you do on that first one? Hopefully you got that one correct. Let's check out this second one. Okay, we have our a term is going to be 4. We know it's going to be minus. We got negative 2 times our a term, which is 4, times our b term. And then we're going to have plus our full b term, which is 6a squared. Okay, 4 squared is 16. 2 times 4 is 8, times 6 is 48. So we've got minus 48a. And then we've got 6a squared, so that's going to give us 36a squared. Hopefully you did those ones correct as well. Okay, so that's going in one direction. Okay, we can also go backwards, right? We can factor. Okay, so it's telling us that if you're factoring and you notice that the first term and the last terms are perfect squares, so we have to notice this. Okay, we can take the roots and then we're just going to check that this 2 times ab is equal to the middle term, and we'll just keep that sign. Okay, so yes, this perfect square trinomial thing works for factoring as long as we notice that those first and last terms are perfect squares and that the middle term just happens to multiply to 2ab. So is this foolproof? Nuh-uh. No. Okay, it's not going to work every time. Is it going to work every time on this video? Yeah, because I've set it up that way. Okay, but this is something that you have to make sure that you check because it's not always going to work the way that you want it to. Okay, so let's take a look. Our first term, I have x squared. My last term, I have 64, which I recognize as a perfect square. Right, so I'm going to take the roots of both of these. If I take the root of x squared, we get x. If I take the root of 64, I get 8. Those are most likely going to be part of my solution. Okay. What I need to check is that if we do 2 times the a term, which we had x, times the b term, which is 8, do we get this number back? So 2 times 8 is 16 times x is 16x. That matches right here. So these actually happen to be the pieces that we're looking for, the x and the 8. How we're going to write that down is x plus 8 inside the parentheses, and we know it's going to be to the second power because it's a perfect square trinomial. So that's how we're going to write down our factored answer. Okay. If that went a little fast, we got another couple examples to look at. Okay, let's take a look. I notice my first term and my last term, they're both perfect squares, right? I have to recognize that. If I take the root of x squared, I get x. If I take the root of 121, I get 11. What I need to check is that 2 times the a term times the b term does it equal what we get in the middle? 2 times x times 11 is 22x. So does it match? Yes. Now what we're going to do this time is we're going to take the sign that's with it. Right? Before we had a positive, so we kept the sign on the positive. Now we have a middle sign of negative, so we're going to include that as part of our answer. So our final answer, we have x, we have 11, and we want it to be minus in between, and we're going to square it. Two more examples, and then you can try a couple on your own. Of course, at any point, if you want to try them out on your own, you can pause the video and go for it at any time. Okay, let's try these ones out right now. I notice my first term and last term are perfect squares. When I take the roots, I get 5 and x. Now I check. 2 times 5 times x. What does it give me? 10x. That matches. I want to use that particular sign. And important here, I want to make sure that I stay in order. Right? I want the 5 and then minus x. I don't want to switch it for any random reason. 5 minus x squared. That's going to be our final answer here. Okay, we got one more. Here I notice in front of x, I've got a 9 and the x squared. But that's still okay because 9 and the x squared, those are both perfect squares. So I can take the root of both of those and I get 3x out. I take the root of 49 and it gives me 7. Okay, that's fine, right? What I need to check is 2 times my a term, which is 3x, times my b term, which is 7. What do we get? Let's see, 2 times 3 is 6, times 7 is 42x. Does that match? Yes, it does. The sign that they gave me was negative, so what I'm using here is 3x minus and 7. 3x minus 7 squared. Okay, so you have 3 examples to try out on your own. Pause this video, try them out, and resume it when you're ready to check your solutions. I'm sure that you're going to do fine with this. Alright, let's check out how you did with these. If we take the root of our a term, we get x. If we take the root of our final term, we get 14. And then we're going to check. 2 times x times 14, that gives us 28x. That matches with our middle term, which was positive. So what our solution should be is x plus 14 all squared. Our second problem, we've got 25a squared. That's all perfect squares here. So we can take the roots. That gives us 5a. Our last term, another perfect square. We're going to take the root. That gives us 2. If we check 2 times 5a times 2, let's see, that's 1020a. That matched what we had. We're going to keep the sign. So we want 5a plus 2 all squared. You had one more you try problem right here. We're going to take the root of the first term, which is 6. We're going to take the root of the last term, which is just plain old p. We're going to do 2 times 6 times p. That gives us 12p. That matches. Let's take that middle term sign. That gives us 6 minus p all squared. Not so bad, huh? Hopefully you got those all correct. If you have any questions about perfect square trinomials, either expanding them or factoring them, leave your questions in the comments or bring them into class and then we'll talk about them there.